All right, good morning. It's now approximately 10:25 a.m. here in Arlington, Virginia at the Crystal Gate Marriott, 14th floor. And in my final sessions, I want to do the Norton theorem. In previous sessions, I have done the Thevenin's theorem, and Norton's theorem is an halide or a relative of the Thevenin's theorem. Now, the Norton theorems state now that if you have a circuit, say now, and as usual, my name is Dolphy Gilpin. And if we have, say now, a circuit, and this is a linear circuit, Norton theorem states now that any linear circuit with terminals A and B, as it is here now, can be replaced by a single equivalent source, current source, IN, in parallel with a single resistance, RN. So that any linear circuit with the terminals A and B, it can be replaced by a single current source, IN. IN stands for Norton, the Norton current, in parallel with a single resistance. And that single resistance is called Rn, R Norton. And we'll see that R Norton would be the same as R Thevenin's for the same circuit. Now, based on this definition now, if we apply this to a circuit now, let's take a circuit. And I hope this writing is not fine enough, or it is large enough rather. And say we have a circuit now, and this is say R1, which say 4 ohms, and R2, which say 6 ohms, and that's a terminal A and B. Then if we wish to find the Norton equivalent, we're going to find some I Norton by short circuiting. And we get the resistor, the Norton resistor, and the current, the I Norton current. First, let us do the short circuit. So we short circuit the terminal A and B. This is A and B, so we short circuit A and B. So we attach a short circuit to it here. And we find R Norton by short circuiting this voltage source. So if we short circuit the voltage source, we find R Norton. So let's short circuit in our mind, draw a straight line through it. So what we'll have here now is that the 4 volts, the 4 ohms will be in parallel with the 6 ohms. And that equivalent will be R Norton. So we say now that R1, R2 over R1 plus R2 is equal to 4 times 6 over 4 plus 6 That's equal to 24 over 10 equals to 2.4 ohms. Yeah, we short circuit this voltage source and we get 4 ohms in parallel with 6 ohms, and that is 4 times 6 over 4 plus 6, and we get 2.4 ohms. And so this is equal to R naught. You know that this would be the same Thevenin's resistance, R Thevenin. Now step 2, that will be step 1. Step 2, we find out, we short the terminal A and B, and the equivalent resistance of the short circuit in parallel with the 6 ohm resistance. So the equivalent resistance, which how we shorten this now, in parallel with the 6 ohm resistance would be just a short circuit here. So that will be 0 resistance. So we'd end up just with a 4 ohm resistance. So once again, we short circuit the terminal AB, and so the equivalent resistance of a 6 in parallel with the short circuit will be just a short circuit. And so we find out that R Norton, I Norton, will be equal now to V over R, and that will be equal now to 10 over 4 is equal to 2.5 amps. Yeah, after we short circuit here, we join here in short circuit, we're only left with 4 ohms. This would be the 4 ohms we're left with. So that now I Norton would be I equals V over R, R Norton, and V is the 10 volt source, so we get 2.5 amps. And now, the Norton equivalent circuit now would be now, draw the current source here. And that's the 2.4 ohms that we calculated here. And this is I Norton. We calculated to be 2.5 amps. And this is now A and B. So we get I Norton equals 2.5 and in parallel with 2.4, and that will be equivalent Norton, or the Norton equivalent circuit. So the concept here is as the basic definition of the Norton is that if we have any circuit, linear circuit, terminals A and B, that we could replace it with a current source in parallel with equivalent R Norton or resistant. So we replace it with a current source and in parallel with resistance, and that would be the I Norton and the R Norton. And we know that the relative relation or with or the comparison with the Thevenin's equivalent circuit, in which we replace it by one circuit with a Thevenin's voltage in series with a Thevenin's resistance. This is, you replace it now with a current source in parallel with a Norton resistance. So that's the basic of the Norton theorem. So with this now, we could go on now to calculate some more Norton equivalent circuit with the I Norton and the equivalent Norton resistance.